So outside the back of my house, I have a dishwasher and a washing machine dedicated for hedgehog-related cleaning. And one day the dishwasher stopped working, so I need to figure out what the problem was. And the first thing I did was check the fuse, because there was no activity on the actual dishwasher itself. And the fuse was fine. So I went back to the dishwasher and I thought, well, there's only one part of this that's actually exposed to the elements, which is the front of the dishwasher, because the back of it's not going to get wet. And I unscrewed all the front of the dishwasher and looked inside, but I couldn't see any problem. It all looked very dry and there were no like scorch marks or anything like that. So I just put it all back together and flipped it over and looked at the bottom of the dishwasher. Now immediately, once I flipped over, I could see that there are worms crawling around the bottom, and it's not actually sealed. If there's a leak inside, water will just pour out of it. So there's holes that wildlife can get into the dishwasher. I looked around and I couldn't see any particular wet patches or anything like that. I thought there would be a leak or something, but actually no, there was no issue. I then sort of moved on to the control box and took the case off, and then immediately I could see what the problem was. A slug had committed suicide across the mains on this control board, and you can actually see the exploded slug residue on the actual case of the control box itself. It was pretty disgusting. So I got the board and I got some isopropyl alcohol and a toothbrush, and I scrubbed off the slug juice from the board and took it inside to see what actually happened, what damage this slug had actually done to the board. So annoyingly, I didn't even record this bit on video, but what happened was I looked at the PCB and you can see there's a burnt out trace on the board itself. And this is where the slug died. So this is the crime scene. And I immediately thought, well, that's clearly supposed to be a trace. So there's supposed to be copper connecting this pad to this pad. And I thought, well, pretty simple solution. I'll just solder a wire across it. So I did that. And for the rest of the investigation into what the hell was going on with this board, I had this trace soldered with a piece of wire. So I debugged the rest of the board, and one of the fuses had blown in the slug incident, and that was all I could really see that was a problem with the board. And one of the power resistors had exploded as well. So I replaced the power resistor with a new one and plugged it in, connected it to the mains, turned it on, and the power resistor just exploded. 3, 2, 1. So I was confused, and I thought, okay, well maybe it's this black component. I tried scraping off the coating on it, but I couldn't see any sort of number on it. I had no idea what was going on. I tried to find a service manual. I did find one, but there was nothing really that useful on the actual circuit layout that could really tell me what it was. I'm pretty sure it's a bridge rectifier. So I was really confused, and eventually, after blowing up several power resistors, I just gave up and ordered a new board on eBay for about 27 quid. And the new board arrived, and it was different. It was slightly different. It was a newer version. I could see on the date that it was several years newer, and there were also some I think it had more air gaps, so it had clearly been iterated on and improved. And I thought, oh, okay, well maybe it'll still work, because how much really does a dishwasher need to be improved? Realistically, do they really need to upgrade that many parts? It's a dishwasher and it works as a dishwasher. So anyway, I put it inside the dishwasher, turned it on, and nothing happened. It didn't respond. It seems that it couldn't communicate with the control panel on the front of the dishwasher. So I took the board back inside, plugged it all into the mains, and tested it to see what was going on. I could see that it was producing 5 volts on the 5 volts rail, and it seemed to be correct. And I plugged in a logic analyzer to see if there's anything I could gain in terms of information about how it worked. But I couldn't. It was some binary protocol. I couldn't work out what it was. So I compared the boards. I put them next to each other and had a look at the differences between them, and I could see that they were pretty much the same. But one strange thing was that this one didn't have a trace across where the other one did. And well, I say the other one did. The other one did now that I'd added one. And I then realised that the arc was just conducted by the slug juice. It wasn't actually a trace that was burning up due to a short circuit. It was slug-induced PCB burn So I removed the unnecessary trace and moved the components from the working board over to the other one, including the power resistor and the what I believe is a bridge rectifier, and plugged it in to the mains on the bench, and it didn't catch fire and it didn't explode, which was really good. So I thought, okay, well now I've got a chance of it actually working. Took it down to the dishwasher and I plugged it in and pressed the power button and it turned on. Behold. And I was like, yes, I cannot believe it. My entire investigation was a complete waste of time because I assumed that the damaged PCB burn mark was actually a trace originally, but it wasn't. One thing I also did was to wrap the control box in duct tape this time so that hopefully no other creatures can actually get inside and become electrocuted. So I plugged it all back in and plumbed it back into the wall and it worked.